Good afternoon, all. Am I audible? Yes, sir.
Yes, sir.
Okay, thank you. Good afternoon. I welcome you all for the today's class. With regard to the discussions in the previous class, I think we discussed about the basic fundamentals of the kinematics of machinery. And what are the things we discussed in the previous class? We discussed about link or element, then followed by kinematic pairs or joints, then kinematic chain, mechanisms, then finally machine. So what is meant by link? What definition I have given for link? Can anyone respond, please? What is the definition for link? It is a
Sir, it is a body that has relative motion with respect to another body.
okay. It is a as he. What's your name?
CB Surya.
Okay, pa. As we said, the link is nothing but it is a motion transferring element. Okay, any mechanism you consider, definitely we will have certain links. Okay, simply we discussed a binary link. Okay, a two-noded element. So for motion transferring is happening between the nodal points, that is motion transferring points 1 and 2. Okay, either you can fix any other links at the motion transferring points so that the motion is being transferred. When you can say a kinematic pair, when two different links are being connected. For example, already I'm having a link that is 1 and 2, and that means no motion transferring point, that is link 1. If I connect another link, okay, if I connect another link with the previous link, then it is said to be what? Yeah, kinematic pair. Joint is nothing but the connection between the links 1 and 2. So this is my link 1, this is my link 1, and this is my link 2. Okay, if the connection between these two, this particular point is joint. Pair is nothing but connection of two different links. Here link 1 and link 2 are connected so that it forms a kinematic pair. So அடுத்த kinematic chain எப்பப்பா சொல்வீங்க? When you can say a kinematic chain? Let me draw here. When you can say kinematic chain?
When 2 and 3 are connected.
Okay, when you have more than two links or
More than two pairs, sir.
Yes, more than two links connected like this. It is a kinematic chain. Okay, so this may be 0.1, 0.2, 0.4, and 0.5. And this may be link 1. This is link 1. This is link 2. Then this is link 3. Then this link 4. And this link 5. So here we are having 5 links connected so that it forms a kinematic chain. Okay, it is not a kinematic pair. Only 2 links are connected, then it is called as kinematic pair. When more than 2 links are connected, then it is said to be a kinematic chain. So எப்போ kinematic chain வந்து can say it is a mechanism.
It's an assemble of chains, links.
So here also it is assembled.
Sir, it is fixed.
Yes, at least one of the links is fixed. அப்படிங்கிற கேஸ்ல மட்டும்தான் then it is said to be what? Kinematic, I'm sorry, mechanism. Okay, இப்போ வந்து இது kinematic chain மட்டும்தான். It is not useful for transferring motion, or it is not being used for power generation or anything. Okay, so now I'm going to fix the link 1. Okay, this is a symbol for fixity. Okay, so now I fix the link 1 so that if I give input to the link 2, if I give input to the link 2, I can expect a predictable output at the output link. So here link 5 is going to be my output link. Okay, in input 2 kuduthanna, then obviously I will get output. I can extract output at the output link. So what is the output actually? What is the output here? The movement of
Link 5, sir.
That is link 5 is giving output, but what kind of output we are extracting?
So motion.
Motion transfer.
Motion.
Okay, so the link 5 may move oscillate like this. Okay, sometimes if you take any other examples, it may slide. Okay, depending upon the requirement, the output can be extracted. So input, sometimes input may be a continuous rotation. Okay, continuous rotation. Output may be linear, that is sliding motion. Sometimes the input may be continuous rotation. Okay, continuous rotation. Output may be some rocking action. Okay, so your link, suppose if this is your link, this is your link, it may rocking, so oscillate like this. Okay, sometimes input may be partial. Okay, that is input may be sometimes linear to and fro motion. Output may be a continuous rotation. So depending upon the requirements and applications, we need to choose our motion requirement. Okay, so in this example, assume this particular link 2 is going to be rotated continuously. Okay, so continuously it is rotating 360-degree, but output can be rocking. Okay, so it may be oscillate. Okay, so to certain angle, so that is from here to here, it may rock, it may have rocking action. Okay, so this is mechanism. Okay, so when you can say it is a machine? Mechanism வரைக்கும் பார்த்தாச்சு. When you can say it is a machine?
Sir, when more mechanisms are present, sir.
Okay, when more mechanisms are being present, and moreover that particular mechanisms are used for some applications. Okay, some
Yes, sir.
power generation or doing some operation like in machine tools. Okay, so அந்த மாதிரி கேஸ்ல மட்டும்தான் அந்த machine tools machine சொல்லுவோம். Whereas simply mechanism மட்டும் இருந்துச்சுன்னா that is not a machine. Okay, for example, you look at this mini drafter. So mini drafter எல்லாமே நீங்க யூஸ் பண்ணியிருப்பீங்க. So mini drafter பார்த்தீங்கன்னா here we here this is the fixity point. Okay, we are fixing in the board, drawing board. So this is assume that is link 1 frame. Okay, so this is link 2, this is link 3, and this is your the scale is your link 4, for example. Okay, so this is particularly used for doing some that is drawing operation. Okay, so it is having certain links. Okay, in the links எல்லாம் வச்சுட்டு என்ன பண்ணலாம், drawing போடலாம். So do you think that this particular link, this particular mechanism is going to be useful for generating some power or doing some operations like in machine tools, machining இல்ல அது மாதிரி யூஸ் பண்ண முடியுமா? No, it cannot be used. So இது வந்து என்ன பண்றோம், இந்த hidden lines எல்லாம் it indicates that it can be moved over the drawing board or drawing sheet to draw some drafting work. So அதுக்கு தான் யூஸ் ஆகும். It cannot be used for power generation. So இங்கேயும் பார்த்தீங்கன்னா automatic door closer. So this is your frame. Okay, door கூட attach பண்ணிருப்பாங்க. Then this is your link 2, and this is your link 3, and this is your link 4. So it will be used for opening and closing. It can't do any useful power generation. Okay, it is a mechanism, but it is not useful for generating power. So as madam suggested in the first class itself, all mechanisms cannot be machines. Okay, but machines can have some definitely mechanisms. So automobile எடுத்துட்டீங்கன்னா definitely you will be having what mechanisms, நிறைய mechanisms இருக்கும். Then those mechanisms are used for power generation. It's clear?
Yes, sir.
Okay, so you are having link, then kinematic pair, kinematic chain. If you are having more links connected together, it is called kinematic chain. Then at least one of the links is fixed and input is given to one link and output can be extracted in the output link. That means it is mechanism. When this mechanism is used for specific applications like automobiles or machine tools, then it can be used for doing some useful work. Then it is said to be a machine. Clear? Okay.
Okay.
Next we move on to planar mechanisms. So as far your syllabus is concerned, we are going to deal only planar mechanisms. So we are having normally two types of mechanisms. Whatever may be the mechanisms we are having two types. One is planar mechanism and another one is spatial mechanism. Spatial mechanism. Planar அப்படிங்கிறது என்னன்னா, you read the definition. When all the links of a particular mechanism have plane motion is called planar mechanism, which means that all the links in a plane mechanism, planar mechanism, move in a plane parallel to the reference plane. Assume this, please mute for someone. Someone is making noise. So assume your drawing board here. Okay, your drawing board is here. Okay, if you take your drawing board is as a reference plane, you take your drawing board as reference plane. Your all the points in the mechanism, consider all the points in the mechanism is going to move parallel to the reference plane. Okay, it cannot move other than parallel to the reference plane. Correct appa? All points in the given mechanism of the mini drafter is going to be move parallel to the reference plane. Reference plane ku parallel ah move agum. It cannot be moved at any orientation. Okay, similarly here also, it is a single slider mechanism used in IC engines for power generation. So இது நீங்க single slider used for IC engines for power generation எடுத்துக்கலாம், or otherwise you can take this mechanism for compressing the air in the compressor. எப்படின்னு சொல்றேன். So it is going to be a crank. Okay, crank is going to be continuously rotating. Okay, so this is your crank. So this is your connecting rod, and this particular portion, so this particular portion is your slider. The blue color இருக்கிறது பேர் என்னப்பா? What is the name for this blue color?
Cylinder, sir.
Cylinder. இங்க வந்து நம்ம kinematic point of view we can say it is frame. Okay, frame or cylinder. So your crank is going to rotate continuously through 360 degree. Okay, so that your connecting rod is going to make connecting rod is connected to the slider, and the slider is going to make reciprocating motion inside the cylinder. Okay, so இங்க வந்து நீங்க if you assume it is going to be a say IC engine அப்படின்னு assume பண்ணிட்டீங்கன்னா you will be having inlet valve, you are having exhaust valve, so that fuel வரும், compression நடக்கும், power கிடைக்கும், then the power will be transmitted from the slider. அந்த பவர் வந்து எங்க ஆக்ட் ஆகும்னா ஸ்லைடர் மேல ஆக்ட் ஆகும். அந்த ஸ்லைடர் இஸ் கனெக்டட் டு த கனெக்டிங் rod is connected to the crank, so crank will be rotating. So output you are going to extract here. Okay, if you assume it is a IC engine, நீங்க இது வந்து compressor assume பண்ணிட்டீங்கன்னா motor will be connected here at the crank. Okay, இங்க வந்து நான் ஒரு மோட்டர் கனெக்ட் பண்ணிடுவேன். கனெக்ட் பண்ணுன்னா இந்த crank வந்து கண்டினியூஸாக ரொட்டேட் ஆகும். So crank rotate ஆகும்போது your connecting rod is connected to the slider, so that your slider is going to make to and fro motion. So இங்க வந்து inletல air வரும், outletல compressed air வெளியே போகும். Okay, so this is a basic mechanism of this particular basic operation of this particular mechanism. So if you look at all the points in the mechanism, it is going to be act in a parallel to the reference plane. So that's why all these things are called as planar mechanisms. Okay, ஒரு planeல இருக்கிற மாதிரி assume பண்ணிக்கலாம் நீங்க we can. So in our scheme, in your syllabus, we are going to discuss all the mechanisms which are related to the planar mechanisms. Okay, we are not, another thing is spatial mechanism, but we are not going to discuss about spatial mechanisms. Okay, so let me tell what is meant by spatial mechanism. So robo is an example for spatial mechanisms. If you look at this particular point, so in the point என்னப்பா point பேர் என்னப்பா? It is a gripper. Yes, gripper which is used for taking some objects and placing some other else. Okay, so if you look at this particular point, so in the point வந்து throughout 360 எங்க வேணா rotate ஆகும். It is having 3 different coordinate systems. Moreover, all the points, if you look at this joint, look at this joint, you look at this joint, whatever may be the joint, all the points are having coordinate systems in 3D plane. So அந்த மாதிரி கேஸ்ல it is called spatial mechanisms. So we don't have scope to discuss spatial mechanisms. Lastல ஒரு டாபிக் மட்டும் இருக்கும், if time permit we can discuss this, but normally the spatial mechanisms are dealt in PG level. So next we are going to discuss about the definition called degrees of freedom. Okay, any idea about degrees of freedom? I think last class one student has asked, he did not understand about the planar pair. I will explain today. What is meant by degrees of freedom, pa? Any idea? Any idea about degrees of freedom? So please read the definition for degrees of freedom. The number of independent variables required to define the position of the link or element. That is the main definition for degrees of freedom. Or otherwise, the second definition you can call it as number of inputs or controls required to obtain the desired position or movement of the links. So any definition which can hold applicable for degrees of freedom. I can explain how you can understand the degrees of freedom. Now you listen this. This is the object which is in space. Okay, this is the object in space. How many degrees of freedom it is normally having when it is in space, as we discussed in the last class? How many degrees of freedom an object possesses when it is in space? ஸ்பேஸ்ல இருக்கும்போது ஒரு ஆப்ஜெக்ட்க்கு எவ்வளவு டிகிரிஸ் ஆஃப் ஃப்ரீடம் இருக்கும்?
6 இருக்கும் சார், 6 இருக்கும்.
கரெக்ட்பா. As he suggested, I'm not able to view your name. Okay, I'm sorry. So this object can move along x direction. Okay, and this object can move along y direction. Then this object can move along z direction. So மூணு directionல translation நடக்கலாம். Okay, then if you look at the axis, okay, so in the axis பொறுத்து this object can rotate. Okay, in the axis பொறுத்து it can rotate. Then similarly z axis பொறுத்து it can rotate. Then similarly about y axis this object can rotate. So normally if you consider an object in space, it is having 6 degrees of freedom, 3 translational and 3 rotational. So normally 6 degrees of freedom இருக்கும். நான் என்ன மெக்கானிசம் பார்க்க போறோம்னு சொன்னப்போ நம்ம what mechanisms we are going to discuss? Planar or spatial?
Planar, sir.
Planar mechanisms சொல்லும்போது your object is assumed to be in a plane. Okay, assume this is your plane. So your object is here, this is your object. So whenever an object is in space, we know that it is having 6 degrees of freedom. Whenever the object is in plane, how many degrees of freedom we are having?
3 sir.
3. So என்னாகும் 3 degrees of freedom வந்து arrest ஆயிடும். அது எப்படின்னா, if you look at this object, so this object is in the plane. So ரெண்டுக்கும் contact break ஆகாம we need to understand the degrees of freedom. For example, இந்த object வந்து along இந்த directionல move ஆகலாம், then along இந்த directionல it can move. Okay, so 2 directionsல move ஆகலாம். இப்போ z directionனா என்னது? இப்படி மேல மூவ் ஆகுறது. கரெக்டாப்பா? If it is moving out, then contact between these two plane and object will be break. Okay, so அப்போ வந்து அதை எடுத்துக்க கூடாது. So that is not going to be considered as a degrees of freedom. Without breaking the contact, what are the degrees of freedom an object is having? அப்படின்னு பார்க்கும்போது along இந்த direction, okay, இந்த direction மூவ் ஆகலாம், then இந்த direction மூவ் ஆகலாம். Y direction it cannot move because the contact will break. So translation பார்த்தீங்கன்னா முன்ன 3 இருந்தது, now it is reduced to 2. Okay, so only we are having 2 translational when it is in plane, when an object is in plane. Spaceல இருக்கும்போது 3 translation இருக்கும், but planeக்கு வரும்போது it is having only 2 translational motion. Now tell me, how many rotational motions it is having?
1 sir.
1 sir.
1 sir.
1 or 2? 1 or 2?
2 sir.
1 sir.
Clockwise.
Only one. You consider 3 axis here. Okay, 3 axis இங்க மாதிரி assume பண்ணிக்கங்க. About this particular vertical axis only it can rotate. Okay, அப்பதான் contact break ஆகாது. You should understand the contact point also. ரெண்டுக்கும் contact break ஆகக்கூடாது. So about this particular vertical axis it can revolve. So அதான் indication பண்ணியிருக்கு. So it can revolve. So it is called delta theta, for example. So one in the axis பொறுத்து it can revolve. So if you consider the horizontal axis, so other 2 axes, if you rotate this object, definitely contact will break. Okay, other 2 axes iruppa. This is another axis, this is another axis. அப்படின்னு பண்ணும்போது என்ன ரொட்டேட் பண்ணும்போது என்ன ஆகும்? டில்ட் பண்ண வேண்டியது வரும். கண்டிப்பா ஆப்ஜெக்ட் வில் I mean contact between the object and the plane is going to break. So other two translations are being arrested. So only it is having one rotational about the vertical z axis. So when the object is in plane, it is having only one rotation and two translation. So how many degrees of freedom an object is possessing when it is in plane?
3, sir.
3, sir.
ஓகே, ஸ்பேஸில் இருக்கும்போது we are having 6 degrees of freedom. இதுவே நம்ம பிளேனில் வந்து வச்சிட்டோம்னா without breaking the contact, it is having 3 degrees of freedom. Any doubts in this?
No, sir.
Okay, shall we proceed?
Yes, sir.
Yes. Now we're going to discuss, we already discussed so many pairs. Okay, என்னென்ன பேர் பார்த்தோம்? What are the pairs that we discussed? Based on motion between pairing elements, we discussed sliding pair, turning pair,
Cylindrical pair.
cylindrical pair, helical pair, then spherical
Spherical.
pair and planar pair. 6 pair பார்த்தோம். And I told that I will explain what is the meaning for the degrees of freedom later அப்படின்னு சொல்லியிருந்தேன். Now it's the time to explain. Yes. So sliding pair, it is indicated that it is having only 1 degrees of freedom. In careful பாருங்க. So it is your object 1 or link 1. It is your link 1 and it is your link 2. So in the மாதிரி condition, sliding pair or prismatic pair la, we need to understand how many degrees of freedom when the object is having. Assume the link 1 is fixed. The link 1 வந்து fix பண்ணிடுறேன். இந்த link 2க்கு what are the possible motions that I can give? Link 1 நான் fix பண்ணிட்டேன். Link 2க்கு என்ன மாதிரி, இப்போ 3 translation பார்த்தோம், 3 rotations பார்த்தோம். இந்த link 2க்கு what are the motions that I can give?
Sliding only, sir.
Yes, we assume we are having 3 degrees, 3 coordinate axis, x, y and z. Assume it is y and it is z. So one sliding கொடுத்துக்கணும் தம்பி சொன்னாரு. எந்த டைரக்ஷன்லப்பா?
Sir, x direction.
X direction. We can give only one translational, okay, sliding or translation motion along x direction. So in the direction மட்டும் தான் கொடுக்க முடியும். So how many degrees of freedom this sliding pair is having?
1, sir.
Only one. Rotation, எந்த rotation கொடுக்க முடியாது, வேற எந்த translation கொடுக்க முடியாது. It is constrained in such a way that it is having only 1 degrees of freedom. So please try to understand that sliding pair is having only 1 degrees of freedom. So that's what it is mentioned here. Okay. Now you consider the second pair, that is turning or revolute pair. It is also indicated that it is the degrees of freedom is 1. Okay. So it is your link 1, namely bush. Okay, link 1. This shaft is your link 2. Okay, link 2. So this collar, okay, this collar is being here in order to arrest the axial movement of the shaft. இந்த shaft வந்து இப்படி மூவ் ஆகாம தடுத்துரும். Okay, in the collar. So now if I fix my link 2, I'm sorry, link 1, okay, link 1 நான் fix பண்ணிடுறேன். What are the possible motions that I can give for my shaft? Shaftக்கு என்னென்ன motion கொடுக்கலாம்ப்பா?
Turn over a fixed axis of another, sir.
What is it? Any translation கொடுக்கலாமாப்பா?
No, sir.
ஓகே, டிரான்ஸ்லேஷன் எதுவுமே கொடுக்க முடியாது. பிகாஸ் எல்லா டிகிரிலையும் அரெஸ்ட் பண்ணி வச்சிருக்கோம். ஒன்லி பாசிபிள் மோஷன் என்னப்பா? ரொட்டேஷனல் மோஷன் அபவுட் இட்ஸ் ஓன் ஆக்சிஸ். ஓகே, இந்த ஆக்சிஸை பொறுத்து ரொட்டேட் ஆகலாம். ஓகேவா? வேற எந்த ஆக்சிஸை பொறுத்தும் ரொட்டேட் ஆக முடியாது. ஃபார் எக்ஸாம்பிள் 3 கோஆர்டினேட் சிஸ்டம் அஷ்யூம் பண்ணிக்கோங்க, எக்ஸ், இசட் அண்ட் ஒய். ஸோ இந்த எக்ஸ் ஆக்சிஸை பொறுத்து இட் கேன் ரொட்டேட். Z பொறுத்தோ இல்ல y பொறுத்தோ it cannot rotate. So only one rotational motion is only allowed. So it is having 1 degrees of freedom. So a sliding pair is having 1 translational moment, so 1 degrees of freedom. A turning pair is having only 1 degrees of freedom, which is rotating about 1 axis. Okay. Now a cylindrical pair. Third pair is cylindrical pair. It is indicated that it is having 2 degrees of freedom. Okay, so in a previous example, it is revolute pair தான். But here இந்த முன்னாடி கேஸ்ல வந்து collar இருந்துச்சு. In order to arrest the axial movement of the shaft, now the collar is being removed here. In this case, it is being removed. So what is the meaning for this? இந்த shaft வந்து என்ன ஆகலாம்? It can move along.
டிரான்ஸ்லேஷன் மூவ் ஆகலாம், ரொட்டேட் மட்டும்.
ஆமா, இந்த ஆக்சிஸை பொறுத்து ரொட்டேட்டும் ஆகலாம், இந்த ஆக்சிஸை பொறுத்து டிரான்ஸ்லேஷனும் ஆகலாம். So how many degrees of freedom it is having?
2 sir.
2 degrees of freedom. Okay, so cylindrical pair is having 2 degrees of freedom when the collar in the previous example is being removed. Okay, another example பார்த்தீங்கன்னா இப்போ another example for cylindrical pair, flat surface or a floor that you can assume here you are having a roller or a coin. Okay, நீங்க என்ன பண்ணலாம்னா can rotate this roller, okay, as well as it is this flow is also going to be translated. Assume it is a table. Okay, ஒரு டேபிள் மாதிரி வச்சிட்டீங்கன்னா இந்த ரோலர் ரொட்டேட் ஆகலாம், அதே சமயம் இந்த டேபிள் வந்து டிரான்ஸ்லேட் ஆகலாம். ஸோ 2 degrees of freedom we are having. Clear? Next வந்து fourth pair is helical pair. ஸோ அதுக்கு வந்து degrees of freedom வந்து இங்கே here it is mentioned that it is 1. Okay, ஸோ நீங்கள் பார்த்தீங்கன்னா if you consider this bolt as link 1 and nut as link 2, okay, if you rotate this link 2, that is nut, in one direction, rotate ஆகும், அதே சமயம் இந்த சைடு மூவ் ஆகுது. ஆனால் நீங்கள் கேட்கலாம் 2 degrees of freedom இருக்கு, ஏன் why we are mentioning it as 1 degrees of freedom? Any idea?
சார் ஏதோ ஒரு ஸ்க்ரூவோ இல்ல போல்ட்டோ ஃபிக்ஸ்டா இருக்கும் சார், புடிச்சுதான் ரொட்டேட் பண்றோம் சார்.
No, what I'm talking about, bolt fixed இருக்கும், பட் நட்டை ரொட்டேட் பண்ணும்போது நட்டு ரொட்டேட் ஆகுது, ஸோ 1 degrees of freedom நட்டு கிடைக்குது. அதே நட்டு இப்போ டிரான்ஸ்லேஷன் மூவ் ஆகுது. கேட்டா
இந்த மூவ்மெண்ட் நம்ம கண்ட்ரோல் இல்லன்னு நினைக்கிறேன் சார்.
மூவ்மெண்ட் பா
சார் நட்டு ரொட்டேட் பண்றது மட்டும் தான் நம்ம ஹேண்ட்ல இருக்கு.
எஸ், டிரான்ஸ்லேஷன் நம்ம ஹேண்ட்ல தான இருக்கு. we can translate.
நம்ம நட்டு ரொட்டேட் பண்றதுனால தான் சார் அது டிரான்ஸ்லேஷன் ஆகுது. அது நம்ம பண்ற மாதிரி இல்லை, அதனால ஒரே ஒரு
எஸ் பா, அப்சல்யூட்லி கரெக்ட். என்னன்னா இப்போ வந்து நம்ம ஒரு கம்ப்ளீட் ரொட்டேஷன் நட்டு கொடுக்குறீங்கன்னு வச்சுங்க. ஃபார் எக்ஸாம்பிள் இட் இஸ் கால்டு ஒன் கம்ப்ளீட் ரொட்டேஷன் இஸ் 360 டிகிரி. ஸோ 2 பை ரொட்டேட் பண்ணிங்கன்னா நட்டை it will move one lead. Okay, leadங்கிறது it is nothing but the distance between one screw and another screw. இந்த distance தான் leadன்னு சொல்லுவாங்க. ஸோ ஒரு கம்ப்ளீட் ரொட்டேஷன் ஆஃப் நட் வந்து it is going to make one lead. ஓகேவா? Do you think that it can be independently controlled? இண்டிபெண்டாக கண்ட்ரோல் பண்ணும், அதாவது நட்டை தனியாக ரொட்டேட் பண்ணும், அதே சமயம் லீடு மூவ் ஆகக்கூடாது, இந்த மூமெண்ட் இருக்கக்கூடாது. இண்டிபெண்டா கண்ட்ரோல்?
நோ சார்,
இட் cannot be independently controlled. இதே ப்ரீவியஸ் எக்ஸாம்பிள்ல பார்த்தீங்கன்னா நம்ம இண்டிபெண்டா கண்ட்ரோல் பண்ணிக்கலாம். அதை ஃபிக்ஸ் பண்ணிட்டு ஜஸ்ட் இதை நம்ம ரொட்டேட் மட்டும் பண்ண விடலாம் ஷாஃப்டை, அதே சமயம் ஷாஃப்டை மூவ் பண்ண விடலாம் இண்டிபெண்டா. ஓகேவா? எனி ஒன் மோஷன் தட் we can attain. whereas இங்கே ஸ்க்ரூ பேர்ல பார்த்தீங்கன்னா if we rotate the nut, okay, in clockwise direction or anti-clockwise direction, ஒரு rotational motion இருக்கும், and at the same time it is going to simultaneously making translation movement. Okay, it cannot be independently controlled. Okay, so even though it is having two motions, it cannot be independently controlled. That's why we are calling it as 1 degree of freedom element. So helical pair, please try to understand, it is 1 degree of freedom element. Clear? So independent control பண்ண முடிஞ்சாதான் that we can call it as 2 degrees of freedom element. So next is last, that is a spherical pair. It is having 3 degrees of freedom. As mentioned in the previous class itself, it can rotate about x-axis, it can rotate about y-axis, and it can rotate about z-axis. 3 different directions we can rotate, whereas translation is completely eliminated. So it is having 3 rotational degrees of freedom. So planar pair, how many degrees of freedom a planar pair is having?
3 sir.
3. So இப்பதான் சொன்னேன். So 2 translation. So இந்த directionல move ஆகும் without breaking the contact between plane and object, and along in the direction it can move and rotation. So in the vertical axis பொறுத்து it can rotate. So another 2 directional rotation வந்து not possible. So it is having 3 degrees of freedom. Planar pair is having 3 degrees of freedom. Any doubts up to this?
No, sir.
Okay. Now we move on to certain mechanisms. How we can identify Okay. So before that, I want to say one more thing. Degrees of freedom for lower pair is 1 degrees of freedom, and for higher pair it is 2 degrees of freedom. So how lower pair is enappa? What is my lower pair?
Surface contact.
Exactly correct. So surface contact between two links. Okay. For example, if you consider the link 2, so this is your link 2 and this is your link 3. Okay, so this link 2 and link 3 are being connected by a pin joint. Okay, or pin joint la connect பண்ணிருப்போம் pin மாதிரி இருக்கும். So the contact between the pins and links is going to be a surface contact. Okay, so surface contact இருந்துச்சுன்னா obviously what degrees of freedom we are having? 1 degrees of freedom. So surface contact இருந்துச்சுன்னா it is called lower pair. So wherever we are having lower pair, it is having 1 degrees of freedom. Okay. Similarly, wherever we are having higher pair, we are having 2 degrees of freedom. Please remember these two things. We want to solve a few problems so that it will be helpful for us. So lower pair it is having 1 degrees of freedom, whereas higher pair it is having 2 degrees of freedom. Because higher pair ஏன் சார் 2 degrees of freedom சொல்றீங்க கேட்டீங்கன்னா, so what type of pair it is? It is a roller or coin which is rolling over the floor. Okay, what type of pair it is? Lower pair or higher pair?
Higher pair, sir.
Higher pair, because the contact between these two is going to be a point contact. So இதுவே ஒரு 3 dimensional இருந்துச்சுன்னா it is going to be line contact. So wherever line contact or point contact we are said to be higher pair. So higher pair க்கு 2 degrees of freedom எப்படின்னா it is going to roll as well as it is going to translate. Okay, translate ஆகும். And we can translate the flow the table also. So two types of motions are possible. So it is called 2 degrees of freedom element. So lower pair it is 1 degrees of freedom, higher pair it is 2 degrees of freedom element. Now you look at before that you see the animation of this one. So it is a 4-bar mechanism. Okay, normally if you look at many applications, we are going to use the 4-bar mechanism. So how we are saying this is it is a 4-bar mechanism. This is your frame. Okay, this gray color is your frame. This blue color is your crank. So crank is rotating continuously 360 degree, and the gray color is your coupler. Okay, coupler means the element or link which connects your input link and output link. So input link is blue color, that is called crank, and output link is your rocker. Okay, that yellow color is your output link, that is also called as rocker. So the element which connects your input link and the output link is called your coupler. So this gray color is your coupler. So the input link, output link and the coupler are connected in a common element that is called frame. So the element pathina this particular whole surface is going to be your frame. Okay, so whenever you are giving input to the crank which is crank here?
So the input link, sir.
Input link, it is going to rotate continuously 360 degree. 360 degree rotate ஆகும், that is called crank. IC engine பார்த்தீங்கன்னா crank வந்து பார்த்தீங்கன்னா 360 degree சுத்தும். ஓகே, இதுதான் கனெக்டிங் ராட் உங்களோட ஐசி இன்ஜின். இந்த கிரே கலர்ல இருக்கிறது அவுட்புட் இஸ் யுவர் ஸ்லைடர் ஆகும். இங்கே வந்து 4 பார்ல இங்கே ஆசிலேட் ஆகும். நவ் ப்ளீஸ் ட்ரை டு லிசன் தி மோஷன் ஆஃப் ஆல் த லிங்க்ஸ். ஸோ ப்ளூ கலர் எப்படி இன்புட் லிங்க் எப்படி ரொட்டேட் ஆகுது, அவுட்புட் லிங்க் எப்படி ரொட்டேட் ஆகுது, and the coupler எப்படி மூவ் ஆகுதுன்னு பாருங்க. Please see this animation and tell me. Are you able to view the crank is rotating 360 degree? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
What the output link is making? When the input link is rotating 360 degree, what the output link is making? Just oscillating, correct or not?
So less than 180 degree.
Less than 180 degree or 90 degree, whatever it may be, it is just oscillating. It's not making continuous rotation. It is just oscillating. That's why it is called as rocker. It is called a rocker. So rocking action mattum pannum, oscillating action mattum pannum. So what the coupler is doing, it connects the input link and output link so that the motion of the input link is transferred to the output link through the coupler. The motion of the coupler is not predictable actually, something but input and output you can easily predict. Input is rotating 360 degree continuously and output is making some rocking action. Correct? So it is a simple 4-bar mechanism. Now I am going to help you to find out how many degrees of freedom this 4-bar mechanism is having. Okay, how many degrees of freedom this 4-bar mechanism is having? So normally a 4-bar mechanism is having 1 degrees of freedom. Okay, 1 degrees of freedom. So the paper on the chin getting now. How many links we are having here? Pa? Evlo link irukku pa?
4, sir.
4. So in the so this one all are, it is going to be considered as a frame. Okay, இதெல்லாமே காமனா frame னு சொல்லுவோம். எந்த லிங்க் கொண்டு வந்து இதில் கனெக்ட் பண்ணாலும் ஃபிக்ஸ் பண்ணாலும் it is going to be a frame. Frame is the rigid element in the mechanism. It is not going to move, which is used to connect the other links. Okay, so நான் சொன்னேன் இல்லையா, எவ்வளவு லிங்க்ஸ் இருந்தாலும் ஒரு லிங்கை வந்து ஃபிக்ஸ் பண்ணாதான் நம்ம மெக்கானிசம்ஸ் அச்சீவ் பண்ண முடியுங்கிறது. ஸோ ஃப்ரேம் இஸ் த ஒன் விச் இஸ் ஃபிக்ஸ்டு ஹியர். ஓகே, ஸோ நீங்கள் இங்கே கால்குலேட் பண்ணக்கூடாது, இங்கே ஒரு ஃப்ரேம் கனெக்ட் கூடாது. என்டையர் சர்ஃபேஸ், இட் இஸ் கோயிங் டு பி த என்டையர் சர்ஃபேஸ். ஃபார் அண்டர்ஸ்டாண்டிங் we are giving like this. Okay, frame is going to be a fixed member, okay, which is called as link 1. So next link edpa, what is the next link?
Coupler.
The coupler, sir, left side.
Yes, crank or input link. Okay, so that is second link. So this coupler is a third link and the output link is your rocker. Just try to remember the names. Definitely rocker, then here crank, and this is called coupler. Then this is frame. This and this are frame. Okay, so I'm saying that the degrees of freedom for a 4-bar mechanism is 1 degrees of freedom. Let me explain how we are having the this 1 degrees of freedom. So normally whenever an object is in space, how many degrees of freedom we are having?
6.
No, we are going to assume it is going to be in a plane. Okay, நான் சொன்னேன் நம்ம இனிமே ஸ்பேஸ் பத்தியே பேச மாட்டோம், பிளான் இருக்கிற மாதிரி.
3, sir.
ஓகே, அப்ப எவ்வளவு லிங்க் பா இருக்கு? 4 links இருக்கு இல்லையா?
4, sir.
4 links இருக்கு. So each linkக்கு 3 degrees of freedom. Each link planeல இருக்க மாதிரி assume பண்ணிட்டீங்கன்னா total how many degrees of freedom we are having?
12, sir.
12 degrees of freedom நம்ம கிட்ட இருக்கும். Now நம்ம என்ன சொல்லியிருக்கோம், ஒரு மெக்கானிக்ஸ் ஒரு கினமேட்டிக் செயினை வந்து இது மெக்கானிசமாக மாற்றணும் அப்படின்னு சொன்னால் how many degrees of freedom, how many links should be constrained or fixed?
5.
How many?
One link.
At least one of the links should be fixed in order to get the predictable output. So இந்த மெக்கானிசத்தில் நான் ஃப்ரேமை ஃபிக்ஸ் பண்ணிட்டேன்னு சொல்லிட்டேன். ஸோ ஒரு லிங்க், okay, one link or which is called as frame is fixed. அப்போ எவ்வளோ டிகிரிஸ் ஆஃப் ஃப்ரீடம் போயிரும்பா? 12லேருந்து எவ்வளோ டிகிரிஸ் ஆஃப் ஃப்ரீடம் போயிடும்?
3 போயிடும்.
ஆமாம், ஸோ 12 minus 3 கண்டிப்பாக இப்போ எவ்வளோ இருக்கும் டிகிரிஸ் ஆஃப் ஃப்ரீடம்? இந்த
9 சார்.
9 டிகிரிஸ் ஆஃப் ஃப்ரீடம் இப்போ டெம்பரரியாக இருக்கு. ஓகேவா? நவ் யூ கன்சிடர் link 1 and 2. Okay, link 1 and 2 மட்டும் கன்சிடர் பண்ணுங்க. So this is your link 1 and this is your link 2. So link 1 and 2 மட்டும் கன்சிடர் பண்ணீங்கன்னா these two are connected. Okay, whenever you connect two objects, definitely different degrees of freedom is going to be affected. So when these links 1 and 2 are being connected at a pin joint, okay, assume it is a pin joint. So pin joint is a lower pair or higher pair?
Lower pairs.
Pin joint is a lower pair. Lower pair எவ்வளவு degrees of freedom இருக்கும்?
1 sir.
1 degrees of freedom இருக்கும். ரெண்டு constraint ஆயிரும். Okay, என்ன constraint? Only with respect to 1, 2 is going to make only rotational. So இந்த மாதிரி rotation மட்டும் தான் ஆகும். வேற எந்த translation ஆகுமா?
ஆகாது.
ஆகாது. வேற எதுவுமே பண்ண முடியாது. Only with respect to 1, 2 is going to rotate. So it is having only 1 degrees of freedom. If you consider link 1 and 2, you are having 1 degrees of freedom. So consider links 1 and 2, link 1 and 2. So என்ன எவ்வளவு degrees of freedom போயிடுச்சு பார்ப்போம். 2 degrees of freedom are eliminated. கரெக்டா? -2. So இப்போ எவ்வளவு இருந்துச்சு ஆக்சுவலா? 9 இருந்துச்சு இல்லையா? 9 இருந்துச்சு. So -2 போட்டீங்கன்னா இப்போ எவ்வளவு degrees of freedom இருக்கு எனக்கு? கைவசம்
7 sir.
7 degrees of freedom இருக்கு. Now you consider the link 2 and 3. 2 and 3 consider பண்ணுங்க. So my 2 is here like this and 3 is here like this. So this is my link 2 and this is my link 3. So 2 and 3 are connected by means of what?
Pin joint.
Pin joint. How many degrees of freedom pin joint is having?
1.
It is a revolute pair. It is having one degrees of freedom. So that is with respect to 2, 3 is going to make இந்த மாதிரி மூவ்மெண்ட் மட்டும் நடக்கும், ரொட்டேஷன் மட்டும் ஆகும். கரெக்டா? அஷ்யூம் 2 ஃபிக்ஸ் பண்றது அஷ்யூம் பண்ணிட்டீங்க, 3 is going to make only rotation movement. So இப்போ எவ்வளவு degrees of freedom அரெஸ்ட் ஆயிருப்பா?
2 sir.
Yes. So consider links 2 and 3. 2 and 3 consider பண்ணீங்கன்னா already I had one. இப்போ வந்து -2 போகுது. So already I had 7. 7 - 2 எவ்வளவுப்பா?
5 sir.
5 degrees of freedom. Similarly 3 and 4 பண்ணீங்கன்னா எவ்வளவு ஆகும்? இதே மாதிரி if you consider the links 3 and 4 எவ்வளவு சப்ட்ராக்ட் ஆகும்பா? degrees of freedom. Same pin joint தான் கனெக்ட் ஆயிருக்கு. Again, if you look at this particular point, it is connected by pin joint. So with respect to 4, 3 is going to make rotation, or with respect to 3, 4 is going to make only rotational movement. So எவ்வளவு degrees of freedom சப்ட்ராக்ட் ஆகும்? So -2. Already எவ்வளவு இருந்துச்சு? 5. So 5 - 2 3 தான்.
3.
ஓகேவா? Now you consider the links 4 and 1. 4 and 1, how these two are connected? By means of, once again, pin joint.
Pin joint.
So with respect to frame, your link 4 is going to make what? Only rotational movements. Okay, it is having only 1 degrees of freedom. So considering 4 and 1, okay, so once again you need to subtract 2 degrees of freedom because it is having only 1 degrees of freedom. So 2 subtract பண்ணீங்கன்னா, so finally 3 - 2 எவ்வளவுப்பா?
1 sir.
1 degrees of freedom. So a 4-bar mechanism is having 1 degrees of freedom. This is a 1 degree of freedom element. That means if you give input, that is one definition for this. If you give one input, so இங்க ஒரு motor connect பண்ணி, okay, இங்க ஒரு motor connect பண்ணிடுறேன். கனெக்ட் பண்ணி அந்த மோட்டரோட ஷாஃப்ட்டை வந்து இது கிராங்க் கூட கனெக்ட் பண்ணிட்டேன்னா, this crank is going to rotate continuously, okay, 360 degree. So I can predict the movement of the output link. So only one input is more than sufficient for operating this particular mechanism. That is another definition for the degrees of freedom. Is it clear?
Yes sir.
Okay, so logically understand பண்ணிக்கங்க. இங்க only ஒரு input கொடுத்துட்டேன்னா I can expect a predictable output at the output link. So that is that can be extracted here. So that is another definition for degrees of freedom. Or otherwise, one more definition we are having for degrees of freedom, only one independent variable. So that is called with respect to frame. Okay, with respect to frame, your crank is making some theta degree angle. இது planeல பாருங்க, front viewல பாருங்க. Okay, with respect to the frame, your crank is making some theta degree. So in the frame இங்க இருக்கும்போது where your output link is going to be. So இந்த பாயிண்ட் எங்க இருக்குன்னு நான் predict பண்ணலாம். So that is also one of the definitions for degrees of freedom. Most commonly we can use 1 degrees of freedom na in the mechanistic ஒரு input source, that is prime mover or motor, is more than sufficient for operating this. That's a definition. One independent variable, okay, independent variable with respect to frame, this crank is making some angle, so that variable is more than sufficient to identify where my output link is going to be. So that is another definition. The third definition is what we have discussed so far. Okay. So if you look at the 4-bar mechanism, it is a simple mechanism. So easily you understood how the links are being constrained and how many degrees of freedom you are having, so that you are able to find out the degrees of freedom logically. Am I right or not? Okay, 4-bar mechanism எடுத்துட்டீங்கன்னா 4 லிங்க் தான் இருக்கு. Easily, comfortably you calculated the degrees of freedom by understanding what I have explained. But practically, if you look at many mechanisms which are consisting of more number of links, okay, நிறைய லிங்க்ஸ் இருக்கும், பட் ஈஸியாக நீங்கள் லாஜிக்கலாக இந்த மாதிரி அண்டர்ஸ்டாண்ட் பண்ணி போட முடியாது. தட்ஸ் வை we are using some criterions called Grubler's equation or Kurzbach criterion. So this particular equation is useful for finding out the degrees of freedom. So sometimes it is called as M னு ஒரு notation கொடுத்திருக்கோம். M is nothing but mobility. Degrees of freedom க்கு another name, it is called mobility. So இங்கே mention பண்ணிருக்கு, the degrees of freedom, or sometimes it is called as mobility, is equivalent to 3 into n minus 1 minus 2 into L minus 1 into H. What is n pa? What is n?
Mobility.
Mobility, sir.
No, M is mobility.
Number of link.
Yes.
Links.
Okay, in order to find out the mobility or degrees of freedom, you need to first find out the right hand side. N is nothing but number of links. You need to identify how many number of links you are having in the mechanism, and 3 into n minus 1 minus 2 into L. So if it is lower pair, so minus 2, but this minus 2 indicates what? Two constraints you are having, correct?
Yes, sir.
Lower pair na minus 2 போட்டிருக்கோம், that is nothing but 2 degrees of freedom are subtracted, and higher pair means 1 constraints you are having. It is having 2 degrees of freedom, 1 constraint இருக்கும், and the 1 constraint subtract பண்ணிரும். Okay, and what is 3 into n minus 1 pa? The 3 into n minus 1 எப்படி வந்துச்சு? நான் இதுக்கு முன்னாடி எக்ஸ்பிளைன் பண்ணது ஷார்ட் ஃபார்ம்ல இங்க கொடுத்திருக்கு, that's all, nothing new. So 3 into n னா 3 into n ங்கிறது எவ்வளோப்பா? n ங்கிறது 4 லிங்க்ஸ்னா 3 into 4 12 வந்திருக்கும். மைனஸ் 3 into 1 என்னப்பா? 3. அப்படின்னு என்ன மீனிங்?
ஃபிக்ஸ்டு லிங்க் சார்.
ஃபிக்ஸ்டு லிங்கை சப்ட்ராக்ட் பண்றோம், அவ்வளவுதான். நான் முன்னாடி சொன்ன கான்செப்டை ஃபார்முலேட் பண்ணியிருக்கோம் இங்க, ஈக்குவேஷன்ஸ் தான். ஓகே, ஸோ 3 into n ங்கிறது 12 degrees of freedom மைனஸ் 3 into 1 3. ஒரு ஃபிக்ஸ்டு லிங்கை சப்ட்ராக்ட் பண்றோம். லோவர் பேர்னா 2 degrees of freedom சப்ட்ராக்ட் பண்றோம். ஹையர் பேர்னா 1 degrees of freedom சப்ட்ராக்ட் பண்றோம். That's all. Okay, so 3 into n minus 1 minus 2 into L minus 1 into H. So this formula is going to be helpful for you to find out the mobility of the given mechanism. Someone is making noise, please mute. Now tell me, what is the degrees of freedom for this mechanism pa? What type of mechanism it is?
4-bar mechanism.
4-bar mechanism. So
4-bar mechanism, sir.
4-bar mechanism, frame is 1, link is 2, and coupler is 3, and rocker is 4. Now you use that equation. And the equation pair enappa? Mobility M is equivalent to what? 3 into n minus 1 minus 2 into lower pair minus 1 into higher pair. Okay. So now tell me, 3 into how many links you are having? N ங்கிறது என்னப்பா? Number of links. How many links you are having? 4 minus 1 minus 2 into how many lower pairs you are having? Over joint or lower pair தான், கரெக்டா? This is
4, sir.
This is one connection between 1 and 2. So one joint, it is one lower pair, and this is the connection between the links 2 and 3. It forms a lower pair. It forms a lower pair, and this is the connection between the link 3 and 4. It forms a lower pair, and this is the connection between the link 1 and 4. It forms a lower pair. So totally 4 lower pair, because all are surface contact. So 4 lower pairs we are having. Minus 1 into ஏதாவது higher pair இருக்காப்பா இங்க? ஏதாவது line?
இல்ல சார்.
Okay, it tends to 0. So So now
Zero.
tell me how many degrees of freedom we are having?
9.
9 minus?
1, sir.
Yes, 9 minus 8, it is equivalent to 1.
1.
So 1 degrees of freedom, or mobility is equivalent to 1 degrees of freedom. Mobility is equivalent to 1. Clear? So நம்ம இதுக்கு முன்னாடி லாஜிக்கலா அண்டர்ஸ்டாண்ட் பண்ணிட்டோம். இப்போ ஃபார்முலா யூஸ் பண்ணி how easily got the mobility. Now tell me how many links we are having for this mechanism?
4.
4, sir.
4, sir.
No, check it. Any other response?
5, sir.
Yes. Who told?
So myself, Prakash.
Prakash said correctly. So 5 links we are having. So frame is going to be your link 1. So this is your link 2, and this is your link 3, and this is your link 4, and this is your link 5. So link 5 is going to make sliding motion along the frame. So this is your frame. Okay, இது frame தான், இதுவும் frame தான். So காமனா இதெல்லாமே frame 1 ன்னு வெச்சுக்குவோம். So link 2, link 3, link 4 and link 5. 5 is your slider. It is going to make sliding motion along the frame. Okay, so totally 5 links we are having. So same formula it is applicable. So m is equivalent to 3 into 5 minus 1 minus 2 into how many lower pairs pa? Hello, lower pair இருக்குன்னு சொல்லுங்கப்பா.
3, sir.
Check it.
4, sir.
Check one.
4, sir.
4 or 5? So,
4, sir.
okay, let me tell. So between link
5,
1,
sir.
yes, it is 5. So between link 1 and 2, it is a connection. It forms a lower pair. Between link 2 and 3, it is a joint. It forms a lower pair. Between 3 and 4, it forms a lower pair. Between 4 and 5, 4 and 5 also surface contact. Okay, அதுவும் pin joint ல connect பண்ணிருப்பாங்க. It is also lower pair. Then 5 and 1. 5 வந்து is a slider. It is sliding over your surface. What type of contact we are having?
Higher path.
Surface contact.
Surface contact.
Surface contact. It is not a line contact. Assume the object is in 3D. Okay, in 3D ல இருக்கிற மாதிரி assume பண்ணிக்கோங்க. Okay, the assume பண்ணிட்டீங்கன்னா the entire surface, bottom surface, it is going to be slide over the floor. Okay, then what type of pair it is?
Lower path.
Lower pair.
Lower pair. So how many lower pairs we are having? So it is also lower pair.
5, sir.
Yes,
Five.
5 lower pairs we are having. So higher pair எதாவது இருக்காப்பா? Higher pair?
No, sir.
Any line contact? No. Now tell me how many degrees of freedom we are having?
2, sir.
Yes, 12 minus 10, 2. 2 degrees of freedom. So it is having 2 degrees of freedom. Either you can give input at this point, okay, or input at this point. So 2 degrees of freedom which this particular mechanism is having. Now moving to this one. How many links we are having, pa?
3 links, sir.
Okay, frame is assumed to be link 1. This is link 3 and this is, I'm sorry, this is link 2 and this is link 3. So formula apply பண்ணீங்கன்னா என்ன வரும்? m into 3 into 3 minus 1 minus 2 into lower pair எவ்வளவுப்பா இருக்கு?
3.
Yes, 3 lower pair minus 1 into 0. So 6 minus 6 அப்பா?
Yes, sir.
Yes, 0 வருது. So what is the meaning for 0? நமக்கு தெரியும் 1 degrees of freedomனா ஒரு இன்புட் போதும். 2 degrees of freedomனா ரெண்டு இன்புட் எங்க வேணா கொடுத்துட்டு ரெண்டு அவுட்புட் எடுக்கலாம். பட் 0 ன்னு வந்துச்சுன்னா what is the meaning?
Sir, you can't move.
No relative motion, sir.
Yes, it can't useful for transferring the motion. Rather than it is used for it is going to be a structure. Okay, whenever mobility is 0 or degrees of freedom is 0, it is called as structure. இது வந்து ஃபோர்ஸ் ட்ரான்ஸ்ஃபர் பண்ணுறதுக்கு யூஸ் ஆகும். இங்கே ஃபோர்ஸ் கொடுத்தோம்னா ஃபோர்ஸை ட்ரான்ஸ்ஃபர் பண்ணுறதுக்கு யூஸ் ஆகும். திஸ் பர்டிகுலர் 3 link mechanism is not going to be useful for transferring motion. So minimum 4 links are required for transferring motion. Now, if you consider this one, How many links we are having for this example?
2, sir.
Yes, link 1 and
2, sir.
link 2. Now calculate the mobility for this particular example. Mobility or degrees of freedom எவ்வளவு வருது செக் பண்ணி சொல்லுங்க.
D into 2 minus 1.
0, sir.
Check once again. 3 into 2 minus 1 minus 2 into lower pair எவ்வளவு இருக்குப்பா? இங்க ஒன்று இருக்கு, இங்க ஒன்று இருக்கு. 3 into 2 minus 1 into higher pair இல்ல 0. Then 3 minus 4 எவ்வளவு
Minus
வருது? Minus 1. So whenever
One, sir.
we are having, so 0 வந்தா it is said to be 0 in வந்தா it is said to be structure. 1 வந்துச்சுன்னா 1 degrees of freedom, 2 வந்துச்சுன்னா 2 degrees of freedom, minus 1 வந்துச்சுன்னா அதுக்கு பேர் என்னப்பா? It's called preloaded or indeterminate structure. So நீங்க engineering mechanics ல படிச்சிருப்பீங்க. So number of equations are greater than or less than number of unknowns, then it is said to be what? Statically indeterminate structure. So அந்த மாதிரி இங்கேயும் minus 1 வந்திருக்கு. It is called preloaded structure or indeterminate structure. So whenever mobility is 0, it is called structure or locked mechanism. Okay. So whenever we are having 1 degrees of freedom, it is called single degrees of freedom constrained. Okay, single degrees of freedom mechanism or constrained mechanism சொல்லுவோம். Whenever we are having more than 1 degrees of freedom, it is called multi degrees of freedom or unconstrained mechanism. Clear? Okay, so depending upon the degrees of freedom, we can name the corresponding mechanism. So
Sir,
yes, ma'am.
sir, if in three link, if it is a open chain, it can form mechanism, no, sir.
Which one? The fourth example.
The third, sir.
It is not open mechanism. It is the third link is connected in the frame again.
Okay, sir. If it is a open mechanism, means it can form mechanism, no, sir.
Definitely. It is going to be a spatial mechanism.
Okay, sir. Thank you, sir.
For that, we can use it for picking and placing another place. Like that, we can use it. Then it form a mechanism. Definitely, you are correct.
Okay,
Let's say
sir.
the third is fixed with the frame in planar mechanism. It is not going to be useful for motion transfer. Clear?
Yes, sir.
Okay.
Yes, sir.
Okay. Next one, the constrained motions, completely constrained, incompletely constrained, and successfully constrained. Three different constrained motions we are having. So what is meant by constrained, completely constrained, which means that the first example, okay, if you look at the first example, so this one, இது பார்த்தீங்கன்னா ஒரே ஒரு ரொட்டேஷன் மட்டும்தான் இருக்கும். கரெக்டாப்பா? As we discussed in the previous class, previous session, it is rotating about one particular axis. So it is called completely constrained. Okay, இதுவே இந்த காலர்ல ரிமூவ் பண்ணிட்டோம்னா டிரான்ஸ்லேஷனும் ஆகும், அதே சமயம் ரொட்டேஷனும் ஆகும். So in that sense, it is called incompletely constrained. Okay, so completely constrained க்கு ஒரு degrees of freedom இருக்கும். Incompletely constrained or unconstrained க்கு வந்து more than 1 degrees of freedom இருக்கும். That's why it is called 2 degrees of freedom or multi degrees of freedom or incompletely constrained. Now third example வந்து பாத்தீங்கன்னா, we are having a footstep bearing. பாத்தீங்கன்னா shaft இருக்கும், இங்க bearing இருக்கும். So இந்த shaft வந்து it can rotate its own axis. Let me erase this. The shaft can rotate its own axis as well as it can slide. Okay, இந்த மாதிரி slide ஆகும். When it is at the bottommost position, a load can be applied. Okay, ஒரு லோடும் அப்ளை பண்ணலாம். அப்ளை பண்ணியாச்சுன்னா இந்த translation can be arrested. So even though it is capable of having 2 degrees of freedom, for example, rotation about its own axis as well as sliding along this direction, so a load can be applied in order to arrest the sliding motion. Okay, so in the Mari case, even though it is having 2 degrees of freedom, a particular degrees of freedom can be arrested. Then in that case, we can call it as successfully constrained mechanism. Okay, so completely constrained, it should have only 1 degrees of freedom. Okay, incompletely constrained, I'm sorry, completely constrained means it is having 1 degrees of freedom. Incompletely means it is having more than 1 degrees of freedom. Then successfully constrained means even though it is capable of moving in 2 directions, 2 degrees of freedom இருந்தாலும் ஒரு particular direction வந்து we can arrest. So in that case we can call it as successfully constrained mechanism. Any doubts?
No, sir.
Okay, so I think it's time. We can discuss in the next class. Any clarifications you can ask me.
Sir,
Tell me, ma'am.
sir, in completely constrained also the motion is constrained, sir.
Yes.
But it has a capable of 2-degree freedom, sir. In successful also the same thing, sir. Then
Yes.
what's the difference between completely constrained and successful constrained, sir?
But in completely constrained, we don't have any 2 degrees of freedom. Only 1 degrees of freedom only we are having.
Sir, if the collar is removed, it can move in translatory and rotatory motion, no, sir?
Yes. When listen, let me show this. Hope you understood the completely constrained motion, correct? It is definitely having
Yes,
1
sir.
degree of freedom. You are having doubts in incompletely constrained and successfully constrained, correct?
No, sir, incomplete, it's clear, sir.
Okay.
Difference between completely and successful, sir.
But difference between completely constrained and successfully
Successful.
constrained means completely constrained you are having only 1 degree of freedom. It is very clear.
Sir, here in completely constrained, the collar is constraining, sir, the motion.
Yes.
Here in successful constraint, that structure, that load is constraining the motion, sir.
Yes.
In both case, some external thing is constraining, no, sir?
Okay. Here, if you look at the first case and third case, it is geometry itself. It is constraining. If you like, if you consider the prismatic pair, pair எடுத்துட்டீங்கன்னா only one sliding தான் இருக்கும். அதுல வந்து geometryலயே உங்களுக்கு வந்து constrained இருக்கும். So it is having 1 degree of freedom. So likewise, please mute me. Likewise, இந்த ஷாஃப்ட்லயும் பாத்தீங்கன்னா இந்த காலர் வந்து it is geometry wise it is constraining. Whereas இங்க வந்து நம்ம ஒரு external load தனியா கொடுக்கிறோம். Then only it is said to be successfully constrained. Okay, geometry doesn't play here. Successfully constrained. Whereas first case prismatic pair assume பண்ணிக்கோங்க. அதுல ஒரே ஒரு டிகிரி ஆஃப் ஃப்ரீடம் மட்டும் தான் இருக்கும். இந்த ரெவல்யூட் பேர்லயும் அப்படிதான். இந்த ரெவல்யூட் பேர்லயும் காலர் வந்து கன்ஸ்ட்ரெயின் பண்ணுது. காலர் வந்து ஒரு ஜியோமெட்ரி, ஒரு ஜியோமெட்ரிலயே நம்ம கொண்டு வந்துறோம். Is it clear?
Okay, sir. Yes, sir.
இங்க வந்து தனியா எக்ஸ்டர்னல் லோடுன்னு அப்ளை பண்ணி தான் நம்ம கன்ஸ்ட்ரெயின் பண்றோம்.
Okay, sir.
Okay. Please wait, let me take the attendance. I think automobile students did not join today. Joined, okay.
Sir, we joined, sir.
Okay.